Hi folks, my name is Syed Jeffrey and I'm a solutions architect at AWS. Today we're going to dive deep into AWS Lake Formation. Let's cover what we're going to look at. We're going to look at why AWS Lake Formation exists as a service and what problems it solves. We'll look at ingest and transform capability within AWS Lake Formation. We'll look at security and access control. We'll look at data discovery and collaboration. And finally, we'll look at auditing and monitoring capabilities within AWS Lake Formation. So to really understand why AWS Lake Formation exists as a service and the problem that it solves, let's look at it from a lens of a real business use case. Let's just say that you're a data engineer at a retail organization and the general manager of your retail business has asked you to build a modern sales forecasting capability. When you think about this problem, the first thing you need to do is to identify the data sources that you need that have the data for that particular use case. In this particular case, you've identified a relational database that has the sales and inventory history data that you need. Okay, great. Next, you'll need to start to build transformation logic that will take the raw data and transform it in a way that can be used for the purposes of forecasting. And finally, because you're operating on the AWS platform, you realize that you have access to a range of AI services that may be able to deliver a much better outcome. And in particular, you've identified Amazon Forecast that can give you a more accurate and a better outcome for this use case. Breaking this problem down further into technical components, the first thing you'll need to do is to set up your data lake, in particular, setting up your S3 buckets. Once you've done that, then you need to start to ingest data from your raw source database and into your data lake. And you need to build an ingest logic that can be run repeatedly, robustly, and more resiliently. Once you've done that, then you need to be able to start to cleanse and prep and transform the data so that it can be used by Amazon Forecast. Once you've done that, then you need to start to think about security and access control. Who has access to what data and what level of access do they have? And how do you manage that access going forward that's easy and scalable? And finally, you need to make that data available for collaboration for all of your users so that they can discover each other's data sets and be able to deliver valuable insights for your business. All of these things are core capabilities that you need to be able to deliver any data project, but at the same time, they can take months to deliver, taking valuable time away from what your business really cares about, which is in this case, an end-to-end forecasting capability. And this is where AWS Lake Formation really comes in, and it gives you these core capabilities out of the box so that you can focus on delivering the end outcome for your business. So let's look at each and every capability in a bit more detail, starting with ingest and register. Let's go into a demo. So I'm logged into the AWS console here. The first thing I want to show you actually is the S3 console. And within S3, you can see that I've created 3 buckets here, the landing bucket, a process bucket, and a published bucket. The landing bucket is obviously where the raw data is going to be ingested into and it's going to land. The process bucket is where the transformed data is going to be placed from landing. And then finally, the published bucket is where the results of Amazon Forecast are going to be exported into and published to. And that's where the end users will actually draw reporting and visualizations from. Now, if I open up the landing bucket, I notice that there are several subfolders within it. And each of these folders represent data sets for the different business units that you have in your organization. And the project that you're dealing with is actually narrowly scoped to the retail domain, and the data will be within that particular folder. And you want to make sure that when you set up your data lake, that the access control and governance is narrowed to that particular scope. Okay, so going back to the AWS console, I'm going to go ahead and open up the AWS Lake Formation console. And I'll click on Dashboard. And I see that there are 3 stages that I need to complete. The first stage is to really register my S3 locations that I created earlier to form part of my data lake. So I'll go ahead and register my landing bucket. And in particular, I will narrow it down to the retail folder so that the Lake Formation scope is confined to the retail folder. And I'll go ahead and click register. Okay, so now as you can see, that particular location is now registered with AWS Lake Formation for the purposes of security and governance. And I've gone ahead and pre-registered the published and the processed locations as well. Okay, next, I'm going to create a database on top of my data lake location. A database will allow me to create logical constructs like tables on my data lake so that my users can easily access and query using SQL. So I'm going to go ahead and create a landing DB. And it will point to the data lake location for the landing bucket. And I'll give it a description. And I'll hit create. Okay, so now you can see that I've created a landing database pointing to the landing S3 location. And I've gone ahead and pre-created the one for processed and another one for published as well. Okay, finally, I need to grant access onto these databases to an IAM role that will be assumed by the various jobs, transformation jobs and ingest jobs that will run to bring data into this and transform the data. So in this particular case, I have an IAM role called LF workflow role. I've selected that and I'm going to give it access on the landing DB. And I want to provide access for it to be create table, alter, and drop. So I'm going to create super, and the super is a combination or union of all three of these access levels. And as you can see now that that role has now got access onto the landing DB. And I've also gone ahead and pre-granted access to the other two databases to this particular IAM role as well. Okay, so now I'm set up with my data lake. The next thing I want to do is to bring data into it or ingest data. So I'm going to use a built-in capability within AWS Lake Formation for ingest called Blueprints. Blueprints give me the option of connecting to a relational database, such as a MySQL, Postgres, Oracle, or Microsoft SQL Server. And I've got two options here, a snapshot or an incremental ingest. I'm going to choose an incremental ingest, which means that it will bring in the first snapshot and then subsequently it'll only bring in the delta changes. For the source, I'm going to select a connection object that I created earlier in AWS Glue that allows me to encapsulate the credentials beforehand so I don't have to type them in each and every time. And now I'll provide the name of my SQL Server database, which is SalesDB, which is my source database with the sales history, and the name of the table is called sales. Next, I'm going to provide the name of the column that this blueprint will use as a bookmark to identify what it has already ingested and what the new delta changes are. And then finally, next I will select the target location for where the data is going to go into, and that'll be my data lake database called LandingDB. File format being Parquet. And I have the option of running it on a custom schedule with the cron schedule, but in this case, I'm going to run it on once a day only. And then I'll give it a workflow name and select the IAM role that I previously granted permissions on, and then a name, a prefix for the tables that this blueprint will create. Okay, I'll hit create. So what this blueprint is doing under the covers is actually creating an orchestrated workflow of individual steps that will be run to reliably and robustly and repeatedly ingest the data from your source database into your data lake. So it's going to go ahead and create that workflow in the background. Here it is. So I'll just click Start Now. Okay, so it's now started. So let's actually have a look inside what this workflow looks like. So let's click on its definition and click on its Run view. And it's taking me to AWS Glue Workflows console. And if I now open it up, you can see that I've got a runtime view of it executing, and started with the first step here, which is the pre-crawl. It'll do a few other crawls, and then it'll do a concurrent ingest from your source database, and it'll finish off with some post-crawl activities. And all of that has been built without you having to write any code. Okay, the other thing I want to show you next is under the covers, how does AWS Lake Formation actually ingest the data? So I'm logged into my SQL query tool here, and I've enabled, on my source database, I've enabled database auditing, which will then monitor all SQL statements. So if I run a query on that audit table, I can see the SQL statements that are being executed by the AWS Lake Formation blueprint. And you can see that it's doing a select star from the sales table, and it's using the invoice date column to determine what it has already ingested and what the new changes are. And this is an important point that I want to talk about here, is the method through which it's ingesting the data. So typically speaking, there are two ways that data can be ingested from your source relational database. One is to basically run a select statement on your source database and bring the data in that way, which is what AWS Blueprint is doing here. The other option is to stream the database changes in from your source data relational database's redo log. Now, there are pros and cons of both approaches, but the thing to be mindful of with this particular approach of doing a select star on the table is that if you have a really busy database and the changes are coming in very frequently, then there is a possibility that this select statement may run in between a live transaction. And if that happens, then you may end up missing the data for that particular transaction. Also, it could also be that these select statements may come in and impact the performance of a really busy database. So if you have operating in those conditions where your source database is really busy, then maybe think about using the redo log asynchronous ingest approach. And if in that case, you can use DMS for that particular purpose. However, if you have got access to read replicas, or your database is not so busy, then an approach like this, which AWS Lake Formation Blueprint uses, can be quite a simple and robust way of bringing the data into your data lake. Okay, so now that we have that set up, it will run for a while. Let's actually look into a bit more detail as to what AWS Glue workflows are and how you can use them for building your use case. So Glue workflows allow you to stitch together individual Glue jobs, crawlers, and conditional logic to be able to deliver a complex outcome. So in your case, because you're building an end-to-end forecasting flow, you'll be using AWS Glue workflows to build your execution logic. This is what it will look like. Data will arrive in your S3 landing bucket, and that will trigger off a Lambda to kickstart the AWS Glue workflow. The workflow will then kick off the transform Glue job so that it takes the raw data and transform it in the format that's usable by Amazon Forecast Service. After that, the Glue workflow will then kick off the 3 individual steps of Amazon Forecast, namely importing the data into the service, training the predictor on the data, and then generating a forecast and exporting the results out to the landing bucket, the published bucket. And finally, the workflow will kick off a crawler to run on the exported forecast dataset so that it's usable via SQL and Amazon Athena and visualized via Amazon QuickSight. So this is what your solution looks like. You have the 3 buckets: the landing, the processed, and published, and the security and governance is managed through AWS Lake Formation. You have the AWS Lake Formation blueprint that's ingesting data from the raw data source and into your landing bucket on a regular basis. You have the AWS Glue workflow that is orchestrating the rest of the automation for your Amazon forecasting process. So starting from transforming the data and then kicking off the Amazon Forecast Service steps, and then kicking off the crawler to run on the exported dataset, and finally sending a notification to business stakeholders via Amazon SNS. Now let's have a look at the demo to see how that actually works in the console. So going into the AWS Glue console again, I'll click on Workflows, and I'll now click on a custom workflow that I've created called Inventory Forecast Demo. And if I open up this, expand this workflow, You can see that I've created each individual step that we talked about earlier. So starting with the transform data step, and then the initiating the importing of the forecast job into Amazon Forecast, training the predictor, generating forecast, and so on. And that workflow finishes and runs the end-to-end forecasting pipeline. So let's go ahead and kick off that particular workflow. And let's open up its runtime view. And as you can see, it's now kicked off the first step, which is the transformation of the data from landing to processed. This workflow will run for approximately an hour or so to complete from an end-to-end perspective. So let's now move on to the next capability, which is security and access control. So AWS Lake Formation groups users into two categories. There's the data lake admins who run and operate the data lake, define and secure the storage, manage the users, and audit and optimize the data lake. And then there's data lake consumers that basically generate insights, consume the data, and sometimes are the custodian of the data sets. So in your case, there are three personas that you need to consider. There's the data lake admin, which is you. And then there's the retail manager, who is the custodian of the data set. And then there's the analyst, who reports into the retail manager and will be running reports and SQL queries on the data, as well as building visualizations. Let's have a look at the demo as to how you would apply security and access control for these personas. So I'm in the AWS Lake Formation console. So I'll click on tables. And as you can see that there are two tables, orders and products, that have been created by the transformation job into the processed DB. And I want to grant access to both of these tables to the retail manager. So I'm going to go ahead and start with giving access on orders table to the retail manager. So click on grant. I will select retail manager, and I will give them select access on that table. Now, in addition to giving them select access, I want to be able to give them a grantable permission, which basically means that they can then self-service themselves in providing anyone else access to this particular table. So that way, I'm getting out of the way and democratizing access and enabling self-service to those who are the custodians of this data set, and in this particular case, the retail manager. Okay, so I'll do the same with the products table. Okay, so now that I've granted those access, I'm going to log in as retail manager using a Firefox container tab, which allows me to isolate user logins. And I'll open up the AWS Lake Formation console as the retail manager. And when I click on tables, I can see that I have access to these two tables, orders and products. And if I open up this orders table, I can see its metadata as well as its schema. And you can see it's got timestamp, item ID, demand, location, and as well as customer name. Okay, so next, I want to show you also, I'm logged in as the analyst user as well, again using another container tab. And I'm going to open up AWS Lake Formation. And when I click on tables here, I see that I don't have access to any of those tables just yet. So the retail manager is now going to self-service and grant access to that table to anyone else, in particular the analyst user. So they'll go in and click grant and select the analyst user, and then they'll give a select access. In addition to that, they want to be able to restrict one particular column from the view of the analyst, in particular the customer name column, because this happens to be sensitive information and they don't want that information to be visible to the analyst. It's not necessary. So they'll exclude that column from view and they'll click grant. Okay, so now that's happened, if I now go to the analyst view and click refresh, I can see that there is an orders table available. And if I click on that orders table as the analyst user, I can see that the schema only contains 4 tables. And in particular, it's missing the table, 4 columns, the missing the column, which is a customer name column. And if the analyst now goes ahead and views the data of that particular table, it'll run that query on that table using Athena, and Athena will show
only the 4 columns that this analyst has access to, even though they actually ran a select star statement on that table. So they're oblivious to the fact that there is actually a column name, customer name, because they just don't have access to it. And similarly, if I now use a third-party tool and log into that tool using as an analyst user credential and try and query the same orders table that I have access to now. So if I query that table from this third-party tool using the Athena driver in the background, I can only see the 4 columns that I have access to as an analyst user. And that's because Athena is the driver that this tool is using, and Athena once again integrates with Lake Formation and filters those columns out.
Let's dive deep into how security and access control works within AWS Lake Formation. So when a user issues a query into Amazon Athena, the first thing Amazon Athena does, it actually queries AWS Lake Formation for the credentials the user has. Lake Formation looks up the access defined for that user and returns back some temporary credentials as well as a scoped down IAM policy that represents the level of access the user actually has on the underlying data. Amazon Athena uses these credentials and this IAM policy to then access the underlying storage to retrieve the result sets that satisfy the query the user has issued. And then before returning the results back to the user, it identifies any columns that the user does not have access to and filters those columns out and then returns the results back to the user. You can see that in this case, you did not have to grant any direct S3 permissions to any of your users. All of that was managed dynamically by AWS Lake Formation and the use of scoped down IAM policy. Okay, now let's look at data discovery and collaboration within AWS Lake Formation. So let's go back to the demo and let's see how we implement that. So I'm into once again in the Lake Formation console, and I have these 2 tables. Now I want to enable discoverability of these tables by others and easy discoverability. So I'm going to go ahead and edit the table, and I have the option of adding custom tags that actually have a business meaning to this particular table. So because this table belongs to the retail domain, I'm going to actually add a tag called domain and call it retail. And I'm also going to add another tag called sensitivity. And because it has some sensitive data in it, I will label that tag to be PII. And I'll hit save. Okay. And now I'm going to go and open up the products table, and I'm going to edit that table as well. And then I'm going to add a similar tag called domain equals retail. Okay, so now that I've added these tags, what that allows me to do is for actually any user of the data lake to be able to search the catalog for tables that have a meaning in the language of the business. So imagine when your data lake grows, you might have from 10, hundreds to maybe even thousands of tables. And how do your users actually discover the data, and how do they collaborate? So if a marketing team wants to be able to use the retail domain data for cross collaboration, how do they discover that data? So they would go into the catalog and they will type in, show me all the tables that belong to the retail domain. So they will type in domain equals retail, and when they hit enter, they'll get visibility of the 2 tables that are available as part of the retail domain that they can use. Similarly, if somebody was looking for any data that had PII information in it, then they could add the search for a tag called CS sensitivity equals PII, and they'll only see the table that has that particular tag. So that it really enables people and users to be able to collaborate, find and discover data and make use of it in the way that best serves the purpose. Okay, so that's one aspect of collaboration, which is that rich data catalog. An important aspect of data collaboration is to be able to visualize the data. In your case, you'll be querying your data, the exported forecasts, using Amazon Athena and SQL. Amazon Athena is an interactive serverless query engine that runs Presto, which is an open source distributed query engine under the covers, and lets you query your data lake using standard SQL. Then using Amazon QuickSight, you'll be able to connect Amazon Athena into a dashboard to visualize the data set, including the exported forecasts for your business stakeholders. If you have a pre-existing preference for a visualization tool of your choice, as long as those tools enable access or connectivity via ODBC or JDBC, they can also be used with Amazon Athena. Okay, now let's look at monitoring and audit capability within AWS Lake Formation. So let's go into the demo again. So I'm logged in as a Data Lake admin into the Lake Formation console. And if I scroll down, I can see a list of all the actions that have been happening on my data lake. So different types of events, as well as the principals or the users that have been accessing or requesting for those events, and also the timestamp at which each of those access requests were executed. So if I open up a particular event here, like get data access, which is executed by the analyst user, and I click View Event, you can see that it provides a very comprehensive set of information about that particular event. So things like, who was the user that requested that particular event, and what was the access key ID that they used, the timestamp of the event itself, the type of event that it was, what sort of data access was it, the tool that they used to execute that event, the type of permissionings that they had at the time of executing that particular request, as well as the table that they actually accessed. So you can see that it's got quite a lot of information and a rich set of information that you can then integrate into any of your tooling for security and events management, such as SIEM, or otherwise any other automation that you want to build to monitor your access. Now, this information is also integrated with AWS CloudTrail. So if I go into CloudTrail and look at the dashboard there, I can see that these events are also being published in CloudTrail. So if I go into all events and search for a particular event name, in this case, get data access, I can see the same information in CloudTrail that I saw in AWS Lake Formation. Now, what that means is that you can integrate CloudWatch logs into CloudTrail, and as a result, build automation on the back of this so that you can create alarms, alerts, notifications based on the type of event that occurred or the type of user that requested that event, or any other condition that you put on. So that rounds off the monitoring and auditing using a single pane of glass within AWS Lake Formation. Thanks for joining this session, folks. I really hope that you enjoyed it, and I look forward to you using AWS Lake Formation to build your use case. Please also remember to fill out the survey for this session. Thank you very much.